Today I will present from modern VR devices to the cocoon in detective connect, analysis the future development of VR and AR devices from a polymer material perspective. When discussing VR technology, people usually focus on processors or displays. However, I believe that material science is one of the key factors limiting future VR development. In this presentation, I will explain how polymer materials influence current VR devices and how future materials may enable technologies similar to the cocoon. VR and AR technologies have advanced rapidly in recent years. Devices such as Meta Quest series and Apple Vision Pro already provided excellent displays and computing performance. However, VR has still not become an everyday product. The most common complaint is not image quality, but weight and comfort. This leads to an important question. If processors keep improving, why can VR devices become as light as ordinary glasses? So currently, there are three representative VR devices currently on the market. Although they target different applications, they all aim to create immersive experience. However, they share one common problem. All of them weigh more than 500 grams. This suggests that main limitation of VR today is no longer software, but how hardware and material constraints. This chart compares VR headset with ordinary glasses. Modern VR devices weigh approximately 500 to 650 grams, while ordinary glasses weigh only 20 to 40 grams. In other words, VR headsets are more than 10 times heavier. If VR devices are expected to become everyday wearable products, significant wear reduction will be necessary. Therefore, weight is not only a design problem but also a material engineering challenge. Many people assume that the battery is responsible for the weight. In reality, the optical lens, displays modules, structural components, and cooling system also contribute significantly. From a material engineering perspective, every component requires trade-off between weight, strength, manufacturable, durability, and cost. Finding the right balance is one of the core challenges in material design. The optical lens is one of the most important components in a VR set. Although glass provides excellent optical quality, most manufacturers use polymers such as polycarbonate and PMMA. The reason is density. Glass has a density of about 2.5 grams per cubic centimeter, while polycarbonate is only 1.2. This means glasses can be more than twice as heavy as the same volume. Therefore, manufacturers sacrifice some optical performance to achieve lower weight and better comfort. This is a classic example of an engineering trade-off. Future AR glasses will require new generations of advanced materials. Polyamide is already used in flexible OLED displays because of its thermal stability and flexibility. Carbon fiber reinforced polymers can reduce structural weight while maintaining strength. Conductive polymers may replace some metallic components, and self-healing polymers could improve durability. This development suggests that the future competition in VR and AR may depend as much on material as on computing power. Now let's move from current technology to science fiction. In Detective Connect, the Phantom of Baker Street, the cocoon allows users to become fully immersed in a virtual world. Unlike modern VR, which mainly stimulates vision and hearing, the cocoon appears to interact directly with the brain and nervous system. This raises an interesting question. What material would be required to make such a device possible? Creating a cocoon-like system will require major breakthroughs in material science, where compatible materials would be necessary for a safe interaction with the human body. Conductive polymers could enable signal transmission, while small polymers might reproduce sensations such as touch or temperature. Self-healing materials will improve reliability and safety. From this perspective, the cocoon is not only an information technology challenge, but also a material engineering challenge. In conclusion, the future of VR depends not only on processors and artificial intelligence, but also on material science. Polymer material already play an essential role in lens, displays, and structural components. However, current materials still cannot fully solve problems related to weight and comfort. Therefore, I believe that the next major breakthrough in VR technology may come from lighter, stronger, and smarter material rather than simply faster processors. From today's VR headset to tomorrow's AR glasses, and eventually concepts like Cocoon, material science may determine how far immersive technology can evolve. Thank you for your attention.